Okay, class, today we're going to do 5-5 inequalities of one triangle. Our objective, apply inequalities in one triangle. The positions of the longest and shortest sides of a triangle are related to the positions of the longest and smallest angles. Angle side relationships in triangles. We've got two theorems here. If two sides of a triangle are not congruent, then the larger angle is opposite the longer side. So what this is saying is, if segment AB is longer than segment BC, then the angle across from segment AB, which is measurement of angle C, is going to be greater than the angle that is across from segment BC, angle A. And then you've got the converse of that. If you have measurement of angle Z greater than measurement of angle Y, well then the segment across from measurement of angle Z, which is XY, it's going to be greater than the segment that is across from angle Y, which is XZ. So let's apply it. Write the angles in order from smallest to largest. Okay, segment GH is our shortest segment. So across from it is angle F, so that's our smallest angle. Then we have 19.6, segment FG, across from it, angle H. And then we have segment FH, measurement of 20.4, across from it is angle G. Write the sides in order from shortest to longest. Okay, we have two angle measures. We need to find the measurement of angle R. Well, because of our triangle angle sum theorem, you can take 180 and minus the two angles that are given and get 48. So the measurement of angle R is 48 degrees. So let's write them in shortest to longest. Across from the smallest angle is segment QP. Across from the next smallest angle is segment QR. And then across from the last angle is segment PR. A triangle is formed by three segments, but not every set of three segments can form a triangle. Segments with lengths of 7, 4, and 4 can form a triangle. However, if you have segments of 3, 3, and 7, you do not have a triangle or a polygon there. So let's apply this. Actually, let's back up. A certain relationship must exist among the lengths of three segments. Okay, so here's your theorem. And instead of trying to explain this theorem, I'm going to go ahead and apply it. I think it'll be easy for you to understand. So if we have a triangle with measurements of 7, 10, and 19. What you're going to do is you're going to take two segments. So let's take 19 plus 7. These two segments have to be greater than that third segment. So 26 is greater than 10. Check. Now we got to pick two other segments. So let's take 19 plus 10. These two segments must be greater than 7. Well, 29 is greater than 7. Check. So then we have our last two, 10 and 7. 10 plus 7 is 17. Well, 17 is not greater than 19. So this cannot form a triangle. And here's how you explain it by showing your work. Okay, I'm going to be quiet and let you do this one on your own. whether a triangle can have sides with given lengths and explain. Okay, now we're going to throw in some algebra here. You need to first substitute in for your variable n to find out what the segment measures are. Now let's apply our theorem here. The lengths of two sides of a triangle are 8 inches and 13 inches. Find the range of possible lengths of the third side. Okay, so let's say we have a triangle with 13, 8, and let's say the third measurement is S. Okay, so let's apply our theorem. 13 plus 8 has to be greater than S. So 22 has to be greater than S. And then let's take S plus 13 must be greater than 8. Solve this like a one-step inequality. And then we have okay, so you have 22 is greater than S, S is greater than -5, S is greater than 5. Well, can we have a measurement of a segment as a negative number? We cannot, okay? So, S is greater than 5, so our least number here is 5. You can switch that around and say 5 is less than S. So 5 is less than S. And then S is greater than, 22 is greater than 5. Well, you can switch that around and say S is less than 22. So your range for that third side is 5 is less than S, S is less than 22. So you're looking at all the numbers that are greater than 5 but less than 22. Okay, same thing. I'm going to be quiet on this one and let you do it on your own. And that's it, guys. Have a good one.